You can see my screen, right?
Yes, sir.
Okay, good. So let's start. Uh, Recall. So just quickly recall whatever done in this week. Then, as usual, we will do some starts with some basic problems. Then we'll go to some good problems. Okay. So uh, with right, with left. Okay. So recall. What is done in this week? Let's quickly recall. So first one is multinomial theorem. So I hope you already know this thing. I'm not going to write. If you don't know, you can ask me. So if S is a set consisting of n1 object of type 1, n2 object of type 2, and nk object of type k, such that summation of ni is cardinality of S, which is n, then this says that number of linear arrangement of all of its element is basically n factorial by n1 factorial, n2 factorial, and so on, so on. So and there is one problem related to this in your today's session. I will do. That is interesting. And the second one is what then? Weak composition theorem. You can help me in recalling. So what is weak composition theorem? Anyone?
Sir, if you have uh, suppose an equation with n variables, and each
Yes.
variable will be at least one.
Yes.
So we have a
Yes.
given
We have
sum for
the
it.
yes. We have a equation in variable. Let's say k variable whose sum is n. Then the and each xi is greater than equal to 0. Then any solution to this will be of the form a1 plus a2 plus ak is n. So which is of the form ordered tuple a1 a2 ak. So this is called weak composition of n into k parts basically. So this will call weak composition. So this I am roughly writing. This is a1 a2 ak. Solution will be look like this. This will call as weak composition of n into k parts. Right. Then there is a composition, right? So composition is same thing, but the solution should be positive integer. And what else? Yes. Anything else? Stirling number is also done, I guess. Partition of a set. Next thing. Mm, Fourth one is partition of the set n into k blocks. What this means? This means partition of a set n, which is basically 1, 2 up to n. This into k blocks means a collection of all its collection of k subsets whose union is full set and which are disjoints. So this is partition of a set. Then we see Stirling number of second kind of second kind, which is denoted as SMK, which is number of partition of n element set into k blocks. This is denoted as a Stirling number of second kind. Then what else? And then we see partition of natural numbers, which is what? Any natural number n has a partition in the form of lambda 1, lambda 2, lambda k, such that lambda I plus 1 is lambda I is greater than lambda. Okay, let me write. So n can be written as a lambda 1, lambda 2, lambda k, such that lambda 1 is such that lambda 1 is, I should write plus, lambda 1 is greater than lambda 2 is greater than lambda 3 is so on greater than lambda k, and second condition is mm, second condition is lambda 1. I already Second condition is, I should write in this way, mm, is a sequence of the form lambda 1 lambda 2 lambda k, such that, and lambda 1 plus lambda 2. I guess this is all what done in this week. If anything else, we will do that at that point wherever it needed. So I guess this is enough to do problem for today's session. Okay, let's go to problems. This week there are literally some good problems, I feel. Okay, so problem number 1. Let's start with this basic. How many surjections F from this 6 cardinality set 1 2 2 up to 6 to 1 2 3, such that f of x is equals to 1 for exactly 1. Exactly 1 x belongs to domain set 1 2 up to so on up to 6. So anyone would like to answer this? Anyone? Any idea? The question is
Three
asking number
partition.
of such. Yes. Can you tell me again?
Uh, is it a three partition?
How?
So each partition will be one of the elements in the codomain map.
Okay, so you are saying 3 partitions of the set 1 2 up to 6,
Yes.
but that is not correct. But idea is correct, but that is not correct, since you are forgetting this condition. You should put this condition also in your mind. Fx is equals to 1 for exactly 1 x belongs to this set. This is also the condition there, right?
This condition is only for the element one of the codomain.
Codomain, yes. One has only one pre-image, basically, this is saying.
Oh, okay.
Fx equals to 1 for exactly 1 x in domain. Can you say something now? But your idea is correct. Just
So
modify that.
we need to pair up one before we do the partitions, I suppose. So pair one into one of the six options, and then the remaining options can be partitioned into two blocks.
Yes, that is correct. That is correct. So yes. So his idea is this. Okay. So let me write what he is saying. So let's let's suppose let x is equals to 6. Suppose x is equals to 1 or so anything. X has 6 possibilities basically. Uh, why let? Clearly, x has 6 possibilities. Once x is fixed, let's say 6, then we have remaining 5 elements है 1 2 1 up to 5 mapping to two element set, 2, 3. So this is precisely Stirling number S5. This is what you said, right?
Yes.
Number of pre-images of 2 and number of pre-images of 3, they will form two blocks of this subset of but can you precisely compute this? What is S52? Hmm?
There is a recursion, but have not yet proved it. There is a recursion that the professor discussed,
Yes,
but I have not yet
you
proved it.
mean, yeah, I got your idea what you are saying. You have this recursion formula there, something S and K basically. So K block subset you are taking. Either this element N will be the element of this set or it will not be element of this set. So if it is a single, if this N is a singleton block, then we have N minus one cardinality set K minus one block. And if this N is not a singleton block, then it will become in some of the blocks. So that will be K, that will be N minus one cardinality set K blocks, and then it will have a K choices. So this will be recursion, I guess you are talking about, right?
Yes, yes.
So how you will use this recursion?
So you have to wind it up. So start
So
from
you
the
want to compute S5 2, right? So that is what this recursion is saying, that basically this is what S4 comma 1.
yes,
So plus K into this is K. What is your K? K is your 2. So this is 2 uh, S4 2. Now what?
S for
Now,
one is one.
S41 is 1. Yes, this is 1.
So we
And
again do the S for two. So
okay,
it
so
will
do
take some
again.
time basically.
Okay, it will take some time. Yes, that is correct. But we can reduce this S22. Once we go to S22, then it will done, right? Then
Yes,
S22 will be
yes,
1.
yes.
So let's do it. This is not much calculation. So what is this? S42. Do the calculation fastly. You can do and tell
So
me the result.
uh,
S42. This is basically again 2. So this is S32 plus K times K is 2. S N minus 1 is 3 and K is 2. So once you do this, what is this? S32, 2S32, 2S32. Am I correct? N
one of
minus
them
1,
should
K
have been
minus.
one.
Yes, it
S3
is have
one.
been. Yes. S31 is basically 1.
S32 should
Yes.
be three, right? I think.
Yes. Let me see. To S31 is S31 is 1 and plus 2 into S32. S32 is basically go to recursion again. You are saying it is 3, but it should be 3, but let's see recursion. This is S22 plus 2 times S22 uh, S22. So just
The
do it.
left one should have had a one. S22. The left S2 should have been S21. Left one.
Yes. So 1 plus 2, what is this computed? 1 plus 2. This is 1 plus 2. This is complete thing. So what is this? So 1 plus 2, 1 plus 2 plus 1, 3 plus 2, 6. 3 to the 6. So this is what? 6 plus 1, 7. 7 to the 14 or plus 1, 15. Right? Correct?
Yes.
So is this correct? But why you need to this much? This is just a basic thing. You know basic set theory. So how you will do this with basic set theory? Let's for some second, because you need to find out number of surjections. So this is your question basically. I have done in your way what you are saying. number of surjections from up to 5 to 2 3. This is what we reduce up to this line, right? Here we reduce up to this line, up to this step. After this, this is the thing, number of surjections from 1 to up to 5 to 2 3 set. So how many total functions from this set to this set? You know this thing, na? Total number of functions from this set to this set. How many functions?
2 to the power 5.
2 to the power
5.
5. Now you remove the constant function.
So 2 minus 2. No, minus, it should be mapped to, can you go up to the question again? Yeah, sure. So there will be one duplicate. One duplicate there should be.
2 to the power 5 minus 1 you are saying? It should be 2 to the power 5 minus 2, na? Total number of function is 2 to the power 5 and two functions are constant functions basically. So number of onto functions are a function which is not onto is constant function in this case, right?
Yes.
So you just need to remove non-constant functions from you just need to remove constant function from total function, that will be number of onto function. So that is basically 2 to the power 5 minus 2. So how many this? What is this number?
30.
This is 30. So our answer is incorrect. Our computation is somewhere wrong. So what we did wrong? Hmm? We have to rearrange this block as well, na? There is also, so there is also two choices in this one, right? Our computation is correct, but once we are fixing these two blocks S5 2, that means we are partitioning this set 5 element set into two blocks. So this, okay, we are correct. So we are, suppose we have these two blocks 1 2 3 4 5. So we have these two blocks. So this block is going to 2, this block is going to 3. Another choice is this block is going to 3, this block is going to 2. So we have two choices for each block, right?
Yes.
Are you getting?
Yes.
Yes. Yes. So yes. So this is the way how to do. So I have to correct what we have right. So this is precisely 2 into S52. 2 into S52. So this. So yes. So required number of onto functions from this set 1 2 up to 6 to 1 2 3. How many? Tell me. How many onto function we have from this set to this set? I determine 1 2 up to 5 to 2 3. Now how many functions I have?
So 2 to the power 6 minus. So we have
6 into 30. That is 180. Correct?
yes.
Yes.
Sir, can you explain
Yes, yes, I will
the
explain. Yes. First, I have to choose fx equals to one choice of x, because x is for exactly one x, the image can be one, right? So x has six choices,
yes, yes.
right? So once we fix one x, let's suppose six I fix, then I have remaining five element set. This five element set has two images. Either it image is any element from this five element set has image either two or three. Suppose image is two, then take the points in domain whose image is two, and take the points in domain whose image is three. This will partition the set, five element set into two blocks. Now each block have two choices because this block can either map to 2 and or map to 3. So the total number of such function from 1 2 3 4 up to 5 to 2 3 is basically 2 into S52. S52 is Stirling number of second kind. Then total number of required function is, first we have 6 choices, then we have 2 into S52 functions. So this is 6 into 2 S52 basically. This is the required thing. I hope it is clear. If not, you can ask me again. I can write again and can explain. Is it clear
Yes, sir.
or not? Let me see how many participants here. Garvita, is it clear?
Yes, sir.
Okay. Okay. So let's go ahead. This is basic problem. Okay. This problem also I I didn't think much about this, but I will tell later. So I don't have a solution for this problem, but you can also think. Let me write this problem. If you have some idea, you can give me. I never thought much about this problem, but this seems to me somewhat tricky. Count the number of composition of 16 with even number of even parts. Oh, I got it. I am thinking this in incorrect way. That will be difficult. What I was thinking, that is difficult. Yes, this is easy. This is easy. I hope we will able to do this. Anyone have any idea how to do this?
Sir,
This will be easy. What I was thinking in this problem while I was why like I just prepared for 1 hour, so I was thinking this problem in this way that even term should be even number. Basically, I am saying x1 plus x2 suppose plus xk is equals to 16. I was thinking this problem in this way, like x2 should be even number, x4 should be even number. If I'm saying this problem in this way, then I hope I feel that this will be difficult problem to do in that case. But what this problem is asking, that will be easy, I guess. That will be not much difficult. So we can think of. So how to proceed? Any idea?
what is, I suppose I don't understand the even parts. What is even parts?
Even number of even parts. So even parts is basically even parts are x2, x4, x6. These are even parts basically.
Oh, okay.
So how many even parts it can have?
Sir, does this mean that even parts are only even numbers?
No, this doesn't mean. That is how I was thinking initially this problem, but this doesn't mean, right? This saying that even number of even parts. Like this cannot have only, let me give you example. X1 plus x2 plus x3 is equals to 16. This type of composition will not be there because this have only x2 as a even part, but it is saying the problem is saying that even number of even part, but it has only one even part. So this composition will not required in this problem. Have you understand the problem?
Yes, sir.
Yes. So give me some idea how to proceed. Any idea?
Sir, in terms of the number of parts,
Mm.
so 2, 4, 6, 8. So if we have 4, we have the only option is to have x1 to I mean uh, x1 to x8 or x9.
Why?
So
I can have up to 16. I am giving you this solution, right? X1 plus up to plus x16
no,
is equals
I'm
to
talking
16.
about cases. The case where there are say only four parts, four even
Okay.
parts with even numbers. So x1 till
Okay.
x8.
Okay.
So
You
two
are
ports.
creating cases, right? Okay. Okay. So your idea is also correct. So you are saying start with cases. Let's suppose number of even parts. Even parts.
So
If this is equals to 1, then this is clearly only one choice. X1 plus x2 is equals to 16, right?
number of even parts, but this will not count, right? So odd number of even parts.
Yes, this will be not counted. So number of even parts is 2. So we need x3 plus x4 also.
Yes.
So so how many solution this have? You know already, right? This is
Yes,
done in
it's
class, I guess.
yes,
How many? N plus n minus 1. N minus 1 choose k minus 1, I guess.
yes,
So this is here n is 16. So 16 minus 1 choose 4 minus 1. So this is 16 minus 1 choose 4 minus 1. So this is 15 choose 3. Then if number of even part is 4, then what?
so so it will go up to 8.
Yes. But why not x9? Why it can not go to x9?
Can it have odd number of any number of odd parts?
The condition is only even parts, not on odd parts in problem, right? Even number of even parts.
Then the casing will not work. You will have too many cases.
Yes, but we have to do that, right?
I think then some other approach is better.
But this is doable. Why you are feeling that this is not correct?
So if you have say
We just
four,
there will be just there will be just two cases, na. Either it can be x1 plus x2 plus x8, or either it can be x1 plus x2 plus x8 plus x9. If we go to x10, then I am not done,
uh,
right?
so you will have the
But
same situation for every or say
i- i-
we'll have to
i-
count for
for
one,
every
3, 5, 7.
yes, for every number I have will be same situation. Two cases, right? Why you are feeling there will be so much cases?
So in even when you are counting events, so
Huh?
suppose you have only you are not considering the odd cases. So you will
Yes.
have 2, 4, 6, 8.
Yeah,
Then
okay, let me tell you what I'm saying. So we consider number of even part 2. So this will have two subcases. Subcase 1 is this, which we consider, and subcase 2 is this. Right? These are only two subcases, nothing more than this. So why you are saying?
yes, I think you can, but there will be 16 sums total.
Yes. And then there is some formula for this. You are, I guess in your class,
Summation, you can sum it up. Yes, yes,
yes,
yes. There is summation
yes,
there.
yes, yes. There will be some formula for this. So compute it. This is the idea to do this problem. Subcase 1, subcase 2. Then similarly, like I should also write another case like case 2, when number of even parts equals 4. Then you have these two choices, right? Subcase 1 and subcase 2. Subcase 1 is basically x1 plus so on plus x8 is equals to 16. So this is 16 choose 7, sorry, 15 choose 7, and subcase 2 is x1 plus x2 plus x9 is equals to 16. So this is 15 choose 8. Then case 3, which says that number of even parts, it's 6. Then there will be also, you have two cases, x1 plus x12 is equals to 16. So this is 15 choose 11, and subcase 2, which says that x1 plus x2 plus x13 is equals to 16. So which says that 15 choose 12. Now the last case, this is that x1 plus, you have number of even parts 8. So there will be only one case in this case. So that will be x1 plus x2 plus x16 equals to 16. So that is what? 15 choose 15. So this is 1. So just sum it up. So number of,
So we can also subtract it, then it will be shorter.
okay, from
To the
complement
power
you are,
Yeah, so I think
but,
uh,
but that will
so
be difficult, I feel. In complement, there are many sets. How you'll find out that?
are we not only can you actually I missed something. Can you yes. So what we have no just the what n choose k we are using below uh 3. Okay. So we have to consider also uh in this case uh 15 choose 1, right? No.
15 choose.
So when you have just one element, so there are oh no, there's only one choice.
That is not considered, right?
Oh, okay, okay. I think I okay.
Basically, this is the idea. If there is something missing, let me know. But I feel that this is the idea. Number of required solution. What is this? Is sum all of our cases. Yes. So this is the idea. Yeah, 0 is also even. So I should consider the case 5 as well of the case 0, where is 0 number of even parts. So that will basically x1 is 16. So that will be only 16. So add 1 also there. So add case 5 also there. So case 5. So number of even part is 0. Is, is 0. So that is x1 is equals to 16. So that is basically one solution of such kind. One solution. So sum all these. Sum of above all cases. That will be the solution. And if you compute this, I'll let me write the solution here and let me know if this computation is correct or not. So solution should be 16384. This should be answer. Let me know next time if this is not correct or it is correct. Is it clear? Idea should be clear. The problem may change in your exam or anywhere you are doing anything. Is the idea is clear?
Yes.
Yes. Okay. Okay. So now do this problem, let's say. this what happened? Okay. Question. Count the number of partitions of 11. Hmm, That's 11 in which the difference of the first two parts, the first two parts is at least 3. So tell me how I should proceed. If you explicitly go to partition of 11, then it will be hard because 11 have too many partitions. So compute that and then doing problem is difficult. So can you suggest me some way? Anyone? To do this? You know the
Can
definition of partition, na? Because I already write, I guess, initially. So then it should be doable. Someone is saying something, I guess. Any idea? This is saying the first and second part. So this means like, so if you are decomposing a number n is of the form this is the partition of this number, let's say lambda 1, lambda 2, lambda k. So this condition is saying that the difference of first two parts, so basically is at least 3. So we know in this decomposition is lambda 1 is greater than 2, lambda 1 is greater than lambda 2. So this condition is saying, the condition is saying what? Lambda 1 minus 3 is greater than equals lambda 2. This is what the condition is saying, right? Or lambda 1 minus lambda 2 is greater than, difference is at least 3. So I should write in this way. Lambda 1 minus lambda 2 is greater than equals 3. This is what the condition is saying. So can you say something now?
uh, no, sir. I actually haven't been able to do the partitions in the lectures yet, so I'm not sure about it.
Okay, fine. So let's try to establish. Anyone else? Only one participant is there. I don't know. I haven't checked. Garbita, you want to give some idea?
No, sir, I'm thinking for that.
Okay, so fine. So let's suppose we are interested in the partition of 11, but this is a big number, so it will have too much partitions. So let's reduce it to some smaller case. So what is this saying? So 11 has some partition, let's say lambda 1, lambda 2, lambda k. So then the condition is saying that we are interested only in the partitions. We want partitions.
Sir,
Huh,
uh,
yes.
even though I'm not sure how the partition part went because I've not watched it, but is the idea something like this? Because the constraint is that the first two should add up to 3, but the
Mm-hmm.
difference should be 3.
Huh,
So um, and the constraint says that the first one should be larger than the
huh,
most.
huh.
So, suppose
So yes,
Sup-
you are correct. Tell me, tell me.
So we can basically get it into two cases, in where the first one we consider the lambda 1 and lambda 2 separately, and then lambda 3 to how many so we can consider uh, just to say mm, the rest of the sum uh, uh, uh,
But that
independently
will be
of.
computation. I am getting your idea. Like what you are saying, that will be again computation. What you are saying, I am getting. You are saying lambda 1 and lambda 2. Let's suppose lambda 1 you 11. Lambda 1 cannot be 11 because you also need to lambda 2. So lambda 1 is 10. Then what is the choices for lambda 2? Basically, you are saying this. So lambda 2 can be 1, lambda 2 can be 2, lambda 2 can be 3, lambda 2 can be. So if 10, then 2, 3 cannot be because 10 plus 1 should be 11.
Only 7 can be, right?
No, this is not correct.
If lambda 1 is 10, then lambda
Huh.
2 must
Can
be
only be
greater than.
1.
Oh, yes, no, sorry. I thought I mistakenly thought it was equal to 3.
Yes. Lambda 2 can be only 1. If this is 9, then it should be 2, and 2 have 2 partition 1 1. So if it is 8, then this is basically, this can be what? It can be 3
3.
and the partitions of possible partitions of 3. Then it's partition all possible cases. Then 7 and this is 4, the difference is 3, so you can do all partition cases. But when once you go to this case, 6 and 5, then you have to consider this case is not there, but it's a partition case will be there. Like it's partition once in the case where the partition is of the form, this partition is of, let's say, this partition, this will become there in that case. Also 6 5 is not there. So there will be many sub cases. You can compute it in that way as well, because this is not much big number. But the idea is, your idea is also correct, but it is quite competitive. There is computation. So idea should be this. What you are saying is correct. Like break this all possible cases and compute what cases are coming there and what are not. I hope you get what you are saying. Huh. So this is the thing. We want to partitions. We want partitions in which the difference of first two parties at least 3. We want partition in which the difference of two parties at least 3. So that means lambda 1 minus lambda 2. The condition is here, same thing. I should not write again and again. Summation lambda I is 11. So lambda 1 minus lambda 2 is greater than 3. That means lambda 1 minus 3 is greater than lambda 2. So focus on this condition and the definition of partition. Can you say something now? Now you should be able to say something. Focus on this condition and definition of this partition. This is the definition. Basically, think for n. Can you give some smaller number bijection of this collection of partition of 11 to some smaller number partition? Can you think something now? You should be able to say this now, because I gave almost full hint basically. You should be able to say now. Lambda 1 minus 3 is greater than lambda 2 and summation of lambda I is 11. So if I am doing summation of lambda 1 minus 3 plus lambda 2, that will be what? That will be what? That will be what? Tell me.
11.
See, summation of lambda uh, 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 we know given this is given na? The partition we consider lambda 1 plus lambda 2 lambda k 11. Now if you consider this one, lambda 1 minus lambda 3 plus lambda 2 plus so on so on so on plus lambda k, this will be 8 na. This will be 8 na, correct?
Yes.
Sir, I have idea here.
Yes, you should have idea now because I gave you everything. So tell me,
Sir, can we use stars and bars here?
can we use what?
Stars and bars principle.
I don't know that principle. What is that principle? Tell me. What is that principle? Because Maybe I know the statement, but not by the name. Can you tell me? So then I can think of. So, so this condition and this condition, what these two conditions are saying to you? This is definition of what? Then lambda 2 is greater than lambda 3. These conditions are already there. So what is these two stars are giving you? Tell me. If you can't see this, even after saying this much, then what I can do? You are not getting what I am saying? At least unmute yourself and tell me. Then I can understand what I am saying is you are understanding or not.
No, sir, I actually haven't done the partition part in the lectures yet, so I am
You
little
don't need to
confused.
done partition. You don't need to done partition. This is the definition of partition. So I gave you definition at the beginning of class, right? So this is the definition of a partition. So given a natural number n, so the partition is a sequence basically of the form lambda 1, lambda 2, lambda k of natural numbers such that lambda 1 is greater than equals lambda 2 is greater than equals lambda 3, so on lambda k, such that summation on lambda is n. So you don't think this as a multiplication since I haven't write it comma here, but this is the convention. We don't need to write a comma when we writing partition, but don't think as a multiplication this. So this is a sequence of the form lambda 1, lambda 2, lambda k, such that lambda 1 is greater than lambda 2 is greater than lambda 3, and summation of lambda is n. This is the definition. Definition is clear? Definition is
Yes,
clear,
sir.
no?
Yes.
Yes. Yes, if definition is clear, so these two things are saying something to you. I am started with partition of 11. I suppose this is the partition of 11. Then the condition is given lambda 1 minus lambda 2 is greater than 3. So that means lambda 1 minus 3 is greater than lambda 2, and lambda 2 is greater than lambda 3, so on is greater than lambda k. So this is first condition. And the first condition, the definition of lambda 1 plus partition is giving you lambda 1 plus lambda 2 plus lambda k is 11. So that means lambda 1 minus 3 plus lambda 2 plus lambda k is 8. So these two conditions are giving you something. This is what? This is partition of 8 now. This is the definition of a partition 8. Provided there is a lambda 2. So have you got the idea? I want to give you bijection. So I wanted to give you this bijection. So this set is, let's say, A. So let me write. Because you are not clear, so I should write. Let A is collection uh, uh, of partitions of 11 which satisfy given condition, given condition given condition lambda 1 minus lambda 2 is greater than 3, and B is partitions of 8 which have at least two parts. So I have given you bijection between these two sets. This bijection. This is bijection basically. And this cardinality you already know. Cardinality of B is basically partition of 8 minus 1. So 8 has how many partitions? This you should, up to 10 at least, you should know. So 8 has 22 partitions. So this is 22 minus 1, 20. So is this bijection is clear or not? This is what the thing you should get in this question basically. Then partition computing is basically computation. So is this bijection is clear or not?
Yes, sir.
Abhishek, is this clear? Abhishek
I
is not there?
can see that 11, if you have 11 and 8, then it's 3, but I'm not exactly clear actually, honestly.
Okay, so let me tell you again. So let's start with A. These are my set A and B, huh? So start with any element of A. So let's suppose A belongs to A. So that means what? A is a partition of A belongs to A means A is a partition of 11 which satisfy the given condition lambda 1 minus lambda 2 is greater than 3. So A is a partition of 11. So that means A is partition of 11. Let's say of A is of the form lambda 1, lambda 2, lambda k, such that the definition, what the definition is, lambda 1 is greater than lambda 2 is greater than lambda k, and summation lambda I equals to 1 to k, this is 11, right? So this is the what is the meaning of A belongs to A. So now the condition is given you that lambda 1 minus lambda 2 is greater than 3. So that means I am giving you a partition, I am giving you an element B belongs to B. So send A to B where P is equals to lambda 1 minus 3, lambda 2, so on lambda k. So what this condition is saying you, lambda 1 is greater than lambda 1 minus 3 is greater than lambda 2. So that means this partition, let's say this as a T1. So this is again a partition because T1 is greater than lambda 2 is greater than lambda k. And summation of them is 8. So that means, and it has two parts basically because lambda 1 lambda 2 is also element there because in A lambda 2 is there, lambda 2 is alive. So here also in B. So that means B belongs to B. Conversely, if B belongs to B, that means B is a, B belongs to partition of 8 and B has at least two parts. Two parts. So that means B is of the form alpha 1, alpha 2, alpha k. So then send B to A by giving B goes to alpha 1 plus 3, alpha 2, alpha k. Then again the given condition hold because alpha 2 minus alpha 1 minus alpha 2 is greater than equals 3 always. Because alpha 1 is greater than alpha 2 here in this condition by definition. So I hope it is clear now. If not, again, you can ask me. Is this clear? Mm.
Sir, both the sets have at least two alphas.
Alphas, yes. Yes, this is the condition. Partitions of 8 which have at least two parts.
Okay.
At least two parts.
Yes.
So I am excluding this partition. 8 has a partition of this form now 7, 1, 6, 1, 1. This form, all this partition. I am excluding only this partition. This has only one part. Remaining all partition have two parts basically, right?
Yes, I get it.
Yes. Yes. Good. I hope it is clear. If not, you can ask me again. So next problem. This is interesting. These all are basic, but now this one is interesting. So, so question. Tell me. What is this notation means 11 choose A comma B comma C? This is done in your class now. What is this notation means? First tell me the meaning of the notation 11 choose A comma B comma C. No one? You are not following lectures because this is done in lecture notes basically. This is your lecture notations. What is this notation means? This
Sir, I have
means
done till Hemchandra recursions.
so before that this is done. Have you done the multinomial theorem proofs? If you have an object, n1 object of type 1, and 2 object of type 2, and 3 object of type 3. This is the thing that
Oh, yes, 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 I remember.
n choose n1, choosing n1 objects from n objects, then choosing n2 objects from n minus n1 objects. So this is the definition. So this is what the definition is. So now you should tell me. So what is this summation? How to do? What should be the idea? So think in this problem in this way. Let me give you idea. Then you will tell me. So you have 11 position. 11 position. Now you have what? You have A, B, C such that A, B, C are three types basically. Among these 11 positions, we have three types of objects to put on these 11 positions. These three A, B, C type of objects. So what are total possible choices basically? We need A plus B plus C is 11 already given to us. So each slot have exactly three choices. Each slot have three choices. So so what is the value of this 11 choose A comma B comma C is basically 3 to the power 11. Is this clear? If not, tell me. I'm not saying this summation value. I'm just giving you 11 choose A comma B comma C value. Such that A plus B plus C is 11. Yeah, I'm giving you this value basically. Yes, I should. Summation over. I'm giving you this value. Is this clear or not?
Yes.
Abhishek?
Sir, can you explain?
Yes, I will say you another way. Let's think in this way. Is this expression clear or not? If this not clear, then I can explain you again. I can explain you then this expression. Is this option? Is this clear? This expression? Let's say start.
How did you get this?
Yes, I should tell you then. This means what? Let's do for some. Okay, let's do for. So what you are doing, you are multiplying this 11 times, no? Sorry.
Yes.
So how many times x to the power a, y to the power b, z to the power c is appearing basically? So when you are multiplying, when you are choosing x slot basically a times, y slot b times, z slot c times. This is basically exactly same as the definition of n choose a comma b comma c. A object of matlab, like a object of type x, b object of type y, c object of type z, right? This is what the definition of this term. Are you getting or not? Hmm? So what is the meaning of n choose a comma b comma c? This is linear arrangement of n objects among which a of type 1, b of type 2, c of type 3. So this is what here, na? A object of type x, b object of type y, c object of type z. So these are basically n choose a comma b comma c. Are you getting me or not, Abhishek?
Sir, I'm getting the sir, in n choose a comma b comma c, we are saying that a plus b plus c is 11.
Hmm.
So um
Here also a plus b plus c is 11, na? Because we are multiplying 11 terms. 1, 2, up to 11 expressions. So x, y, any slot you have to go in one bracket to one slot, exactly one slot. So a plus b plus c should be 11 in this case also. Correct? Are you getting or not? This
I
should be
think I'll
clear.
have to revise it again sometime.
Yes, you can
After
check and let me know if it is not clear. But this should be clear now. Matlab, I don't see what you are not getting. So yes, so put x equals to y equals to z equals to 1. So you have we choose 11 is equals to what? Summation a plus b plus c is equals to 11. 11 choose a comma b comma c. This is the thing because x y z is 1. But what is your problem asking? Your problem is asking a into 11 choose a b c. So now can you say me? Now, if you didn't get previous part, forget this expression. Just remember this thing. Then you can go to home and do the thing what I have done, and then recall. And if you didn't get still, you can ask me in next lecture and at this point also. But just now tell me. So we have to compute this expression where I have written this thing, and I have computed this thing. This thing summation ABC is 11. 11 choose a comma b comma c. Now how I should proceed? I want to wanted to compute summation a plus b plus c is 11. A into 11 choose a comma b comma c. Wanted to compute this thing. Abhishek, can you tell me how I should do this? I have given you this expression. Let me write you for again. X plus y plus z to the power 11 is summation a plus b plus c is 11. 11 choose a comma b comma c. X to the power a, y to the power b, z to the power c. Just think about this expression. Can you tell me now what I should do? No one? This is clear. I want coefficient A as well. So what I should do? I should differentiate with respect to x, na? Why this is taking this much time? Is this clear? You know differentiation, na?
Yes, sir.
Okay. So put x, then again put x, y, z one, you get required thing, right? So this is the required thing we need to. Is this clear or not? If this is clear, then I will ask you a similar problem again. Now you have to tell me. Now you should tell me. Can you tell me now how I should proceed? Tell me now. I have written an expression for you as well. Now at least you should unmute yourself and
And do we differentiate respect to a y x and then y?
yes, differentiate with respect to x. You will get then differentiate with respect to y. So then you need to compute this thing, right? So just put x, y, z one. So you get required thing. I hope it is clear. Now you can do this kind of problem. So is this clear?
Yes.
Abhishek,
Yes, sir.
you can look this kind of problem again if it is not clear. Like I feel that you are not much clear in this, at least this part, how I can write this expression in this form. So you can go home and try to do again. If not, if you didn't get, you can ask me next time. But
Yes, sir.
okay, so let's go ahead. So find the number. Oh, okay, so what is the next problem? Find the, okay, so let's do this thing first. Question. Find the number of weak integer weak integer composition of 20 into 5 parts such that there is exactly first two parts are odd and B is any two parts are odd and other parts are even. So tell me, this is the problem. Hmm. So find the number of weak integer composition. You know weak integer composition, na?
Yes, sir.
Yes. Why it is taking this much time? So I already recall in the beginning of the lecture what is the definition. Such that weak means xi is greater than equals 0. So for how you do first part? Let's start with first part. Exactly two parts are odd. First two parts are odd. So tell me how I should do. First two parts should be odd. That means x1 and x2 should be odd. Can you tell me? And other exactly first two parts should be odd. That means other parts should be even. So how you should tell? How you should proceed?
So the two conditions are different problems, or they go right.
Yes, yes. Do start with first problem. Exactly first two parts are odd. That means x1 and x2 are odd. So odd numbers are of what form? Integers are of the form 2n and odds are form of
20%.
2n plus 1, right?
Yes.
2n plus 1, right? So you can write them in the form of x1 is of the form 2y1 plus 1, x2 is of the form 2y2 plus 1, right? And
Yes.
what is other part should be even because we have exactly first two parts are odd. So other parts are even, that means. So other parts are of the form
2 2y3
2y4 plus 2y5. This is 20. Where?
So with composition of 9, so x1 to x5 is equal to
So that means what?
so you can write
y1,
y1 to y5
y2, y5. This
is
is
equal to 9.
9, right? Correct. So that is what?
So that is we have 9 plus 5 minus 1 choose 9.
This is correct. Is equals to so this is 13 choose 4. So this is now what about second part? Any two parts are odd. Now there can be any two parts which are odd. So we have computed first two parts are odd. So now he's saying any two parts are odd. So how you will do?
So
How
we
you
can
can choose two
multiply
parts
with
among?
5 choose 2.
Yes. So any two parts are odd and other parts are even. So yes, this is easy. So B. So first choose two parts out of five parts in 5 choose 2 way. Then we know by part A, part A. What we know by part A, number of compositions number of composition which have exactly two parts odd, exactly first two parts odd, I should say. Odd is 13 choose 4. So total number of, so by product rule, total number of required choices is equals to 5 choose 2 into 13 choose 2. So this is the answer. We are done. So this is easy. Yes. So let's do next problem. This is clear, na? These both parts are clear or not? I should
Yes, sir.
ask. Okay. Abhishek?
Yes, sir.
Okay. Let's go ahead. Give a bijection between the integer composition of n whose first part is 1 integer composition n whose first part is 1 and integer composition of n composition of n whose first part is at least 2. Tell me how I should do. Anyone?
Sir,
This is simple. You should tell me. Yeah.
so in the first case, it's definitely 1. And in the second case, it's not 1. So in the first case, is it equal?
Let's say again what you are saying. Suppose you are starting with, we have to give bijection between two sets. Now, let's suppose, let me highlight this thing. So the integer composition of n whose first part is 1. Let's say this one by a. This is my a. integer composition of n whose first part is 1. This is set A. And the second thing, let's do this with something like this. Highlight this thing. Integer composition of n whose first part is at least 2. Let's denote this by B. So now tell me what you are saying. You have to give bijection between A to B. Wanted to give bijection between A and B. So now tell me what you are saying. How you will give bijection?
Sir, so first,
So you have, tell me.
so
So, bolo.
in the first A, set A, we can
Okay.
we can say that the first one is fixed. So it's equivalent to giving a partition of n minus 1.
Okay, so A belongs to A. That means A is of the form 1 comma something like whatever you are want to say A to AK.
So this one
Right?
has bijection to any partition with n minus 1.
Partition of yes, of the form A to. This one has a bijection with integer composition of
n minus 1.
This one has a bijection with integer composition of n minus 1. Right?
Integer
So
yes.
this bijection with integer composition of n minus 1. So now what? So what you want to show?
So now, if we want to have always the first term to be 2, we can have another partition with added 1 to the first term always, and we subtract 1 from the right hand side.
Okay, so you want to say let's A belongs to A is of the form. So your idea is correct. I got your idea. So what you are saying is, so A is of this form. So he is saying that add first part. So send f of A defined in this way. F of A is 2 comma A2 minus 1 comma so on so on. This is what you are saying, no?
Yes.
Now what is why this map is what is its inverse image? Like why this is bijection? For any B, injection is clear. For surjection, you say for any B belongs to B. So any B belongs to B will of the form what? First part is at
Starts
least
with
2. So B is of the form A1, B1, so on BK, let's say. And B1 is greater than 2.
yes.
So now how you'll do? So you can send it to what? So this implies there exists A is equals to 1 comma B1 minus 1 comma BK such that f of A अगर हम करेंगे तो that will be why this is bijection? Sorry, I am missing something. So I have to show one-to-one correspondence, na? So I have shown this map is injection. I have to show surjection as well. For any B belongs to B, I have to find out some A belongs to A such that f of A is B. So f of A is B. How I will show f of A is B for some way? How I will show this? Let me think. I am missing something. So, so I have to give some A of A is of the form such that f of A wanted to give A belongs to A such that f of A is B. So that means what? So so how you will construct such A? You should tell me. So first you need one, then you need so that f of A is B up to first time we need one. I think we should not do in this way. Then it is what you give this is injection, but need not be surjection. I can give you a number. Let's say, Abhishek, what you said is your map is injective but not surjective. I should correct you. So I should write Abhishek. This map is not surjective, so not bijection. Why it is not surjective? Because you cannot produce partition of the form 3 comma something something a2 comma ak, because its image lies only precisely in 2 comma a2 minus a1 ak. Have you got it or not?
Sir, yes.
So this is not correct. So I should erase this. But this is injective. Yes, idea is correct. So you should say something more.
Sir, if we say that, mm, say in the first term, when we say that from one in the composition of n,
Hmm.
we had shown that it is same as there is a bijection between composition of n minus 1 because 1 was always the same.
Hmm.
So now if we consider the first term, it's at least 1, at least 2
Hmm.
in the B set.
Huh.
So if we subtract 1 from both sides, so 2 becomes
Okay.
1 and then n becomes n minus 1. So then
Okay.
there would be a bijection. So that's same as composition of n minus 1. So both are compositions of n minus 1.
Okay. So you are, but why this second part is not exactly two? It is at least two. It can be three, four as well. Anything.
Yes,
So how subtract?
okay, okay. Oh. Yes, 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 that can be because we are not restricted to one when we have a bijection with a composition of n minus one. We have already got rid of the first one.
So what you are saying? Can you say again? I didn't get what you are saying.
So scroll up. No, where? Okay, one second.
Huh.
Yes. So we have firstly that the composition of n numbers with the
Hmm.
first part being 1. So that is in
Hmm.
bijection with composition of n minus 1 numbers with any
Hmm.
choice, any choice. So first number can
Yes.
be anything. So
First number.
now,
Yes. First number cannot be anything. First number should be at least two.
no, I'm saying that I'm not talking about part the set B. I'm just saying the set A has composition bijection with integer composition of
Partition of
n minus 1.
integer composition of n minus one. Right. That is correct.
Yes. So
Huh.
then, if we say that when we have that the first part is at least 2, talking about
Hmm.
V,
Hmm.
so the if we subtract on both sides, 2 becomes 1. So if we subtract 1, say on the
Hmm.
only on the first number. So if we
Okay.
subtract 1 from the first number, it becomes 1.
Huh.
And we on the right hand side we have n minus 1. So
So
the
in
first
that
number
case, you are
1,
done. This is the integer composition of both are integer composition of n minus one. But what
yes.
if this first part is three? Then what?
So we can have two. There's no problem with it.
Why? Why? Why?
Oh, why would there be a problem there? If you start with 2,
You
then
should show a bijection then again, na. First part is 2 and first part is anything other than 2. That there is a bijection between them. That's what you are saying.
uh, if you consider if first part is you're saying that it's not 2 but 3. So if we
Yes.
subtract 1, so you have
Huh?
2 and then something, then certainly that composition is in the n minus 1 integer composition.
But that is not correct. This is not bijection what you are saying. What you are saying is incorrect. You can write and precisely you can see, but I feel this is incorrect because that is not bijection. Composition is starting with 2 and composition other than 2. This is not bijection. So your idea is somewhat correct, but you are not correct. In this case, at least you are not correct, I can say. So let me write a function, how I should do, because we have to go ahead as well. So Abhishek, you can write your idea and this is incorrect. You will see. Even I can write, but this will be uh, like, I already see this is not correct. So you can try and see where you are incorrect. So yeah, so you can send f of a as 1 plus a2, a3, so on ak. So this is integer composition of n. So that means fa belongs to b. Now clearly this is 1 1 is clear. Now on to what about on to? So for any b belongs to b, b is of the form b1, b2, bl, let's say, such that b1 greater than equals to. So how you will construct such a such that f of a is b? How you will construct such a? Now it should be clear. So choose a is equals to what? A1, so on al plus 1, such that a is what? A1 al plus 1, such that a1 is equals to 1 and a1 plus a2 is equals to b1, a3 is equals to b2, and so on. Al plus 1 is equals to bl. So this is means what? 1 plus a2 is equals to b1. So that means so that means b1 is 1 plus a2. Yeah. So that means a2 is b1 minus 1. So we can find this thing. So we have a is precisely what? A is b1 minus 1, comma b2, comma bl. So that means f is 1 1 on 2. That means f is bijection. Right? Is this clear? Is this clear?
Sir, what if B is the largest possible?
B is
So in the integer composition,
hmm,
whatever the first number can be, whatever the largest value for the first number can be, then
hmm.
it will be mapped to 1 less. So what about the largest number? So we
I
have 1 less
didn't.
mapping.
We have one less mapping. Where one less mapping you are saying? You want to say this thing? Because this b1 is greater than equals 2. So a2 is non-zero. It should be greater than equals 1. So there is no problem. What you want to say?
Sir, I'm saying that say
Huh.
B1, whatever B1 is, so whatever the largest number for uh, okay, no, okay. Yes, whatever the largest number for B1 is, So then that is getting to mapped to one of a number less than that. So
Huh? So what?
okay, I think there is no problem.
Sorry. I should write this way. Sorry, you are correct. A is this thing. I should write 1 comma b1 minus 1. Yeah, now this is intercomposition of it. Yes, you are correct. Now is this clear? Because otherwise this sum will be n minus 1. So how it will be n? A should be this thing. Yes. A1 is 1 and A2 is b1 minus 1. Then so on, so on. Yes. Is this clear now?
Yes, yes, sir.
Yes, you are pointing on this. Correct. Good. Huh. So next thing. Question. Find the number of set partitions of n set containing 1 2 up to n into k blocks no block is empty such that the element n in n minus 1 always lie in same block. So the question is asking find the number of set partitions of this set 1 2 up to n into k blocks. No block is empty such that the element n and n minus 1 always lie in same block. So how you will do?
Sir, can we pair them up n and n minus 1?
So what you are saying?
Can we pair uh, n and n minus 1?
Okay, so what? You pair n and n minus 1, then what?
Then you can partition into k block. So n and n minus 1 are always together.
Okay, but it can okay, they should lie in the same block. Okay, so what you will do? So you just pair n and n minus 1, then what?
So it becomes the partition of n minus 1.
This become partition of n minus 1. No, why?
So n and n minus 1, let me be clear, n and n minus 1 is exactly the last and one before that. So
Yes.
if you consider them as one element, then you have set partition of n minus 1 elements.
Hmm.
So then you can distribute them into k blocks. So wherever
Yes.
the n minus 1 goes, n goes with it.
Hmm. The idea should be correct. You are saying that n and n minus 1 are together. So you are saying that this is same as the making k blocks of n minus 1 cardinality set. K blocks of n minus 1 cardinality set. N minus 1 k blocks. So what I am computing for my computation, so I am saying that okay, whether they will come as a single block or not. So if they come as a single block, that means that will give you what? Sn minus 2 k minus 1. Sn minus 2 k minus 1. If they come as a different, okay. So whether they will come as a single block or not. So if they come as a single block, then what? So if they come as a single block, so that means this thing is the same thing as a n minus 2 set k minus 1 block. If they doesn't come as a single block, then what? So that means they will contain in some block. So there is a k choice for that block. So that will k into Sn minus 2 into k blocks. So whether these two things are same, I have to check. Can you see whether these two things are same? For my computation, this is the answer. For your one, this is the answer. You are saying
Sir,
this
this
is
is
same thing.
essentially the this is the wait a second. Let me collect myself.
What is the relation, recurrence relation we have? Sn comma k is either n is the element of the. Let's
Yes,
start
I
with the
was saying
singleton.
that the circles you have drawn. So that was the theorem in the lecture.
Yes, this is this theorem in a lecture.
Yes, yes. The thing you have the equality is
I guess
that's
it
the
is just
theorem.
coming. It is just a recurrence relation. I guess because you are starting with an n cardinality set and k blocks from it. So let's suppose you are starting with a singleton set. Either this singleton set will be in this k block a singleton set will be there, or it will be not in containing. Okay. So either this n will be present in k blocks, or I should whether this singleton set is present in k blocks, or whether this set will come some other set. So if this set comes with a singleton block, that means this is same thing as a Sn minus 1 in k minus 1 blocks. And if this set comes as if this set comes with some other set, so then it will have a k choices among Sn minus 1. So this is the recurrence relation we should have. So if you are choosing n is n minus 1 and k is k, so this is n minus 2 k minus 1 and this is n minus 2 k. Yes, this should be correct. Yeah, this is same thing. What you are saying and what I am saying is same thing.
Sir, I have a doubt. Actually, because this, I was supposed to actually prove the right side. I haven't done it yet. So I have a doubt here that when you are saying that you are making n as a singleton block, it could be that n
Yes,
minus one is a singleton block.
yes, anything. I am just saying for my convenience.
Does that not constitute two choices?
No, 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 not at all. Just put this is what this is. You have a set 1, 2 up to n. Na?
Yes.
This is n cardinality set. Fix any element n. So if you are constructing k blocks basically, so that k blocks means you are constructing k sets b1, b2, bk of n such that their union is full, such that union of bi is this full n and intersection of bi is empty. So so what will happen? Either this n will equals to bi for some I. Either this will happen, or what will happen, or this n will contained in some bi. This singleton n will contain in some bi because their union is null. So I am taking both the cases. If this n will come as a single bi, so then so that means same thing is a Sn minus 1 k minus 1. If this n is contained in some bi, so that means n minus 1 have already have k blocks, and I am this n have k choices. This can go into any k blocks. So that is why how we are getting the recurrence.
Sir, can you add the addition part? Can you explain the addition part again?
Yes, we have two choices, na, basically. So this n can be one of the bi. So this n, if this n is one of bi, so in that case, what will happen? That is same thing as n minus 1 cardinality set, k minus 1 block, because this n is a singleton block. If this n will come contained inside some block, let's say bi, so that means this n minus 1 cardinality set already have k blocks, and this singleton n has a k choices. This can go to any block. So this is precisely k into Sn minus 1 k. So these two choices are
Okay, yes, yes, yes. I
yes,
get it now.
yes. So both things are same thing.
Yes, yes.
So do I need to write the proof precisely, or is this clear to everyone?
It's clear.
Participants?
It's clear.
Anyone else is there, or you are only
No,
there?
I
Okay,
think
you are only there, so I don't need to write. Yes. So let's do next problem, and this will be hopefully last problem for today's session. So this will be good problem, not hard but good question. Give a bijection between integer partition of n with distinct parts in integer partitions of n where each part is odd. Hmm. Can you think something in this direction? Give a bijection between partitions of n with distinct parts and integer partitions of n where each part is odd. So let's denote. A is a collection of integer partition of n with distinct with distinct parts and b is collection of integer partitions of n where each part is odd. So can you think something? Suppose you start with a.
that. Yeah, I think I have idea. So
Okay.
each of the odd numbers is 2n plus 1 type.
Okay. Each of the
So
odd number is of the form 2n plus 1. That is correct.
so please let me remind me again. Can is it was the inequality strict? So the first element is always greater than the second element in the partition.
Greater than equals. It can
Greater
be
than
equals.
equals. Oh, okay.
Yeah.
Okay. I don't think then my idea will work actually.
Okay. Let me give you. Then you will think. Suppose you choose A belongs to A. So that means what? A is of the form A1, A2, AK, such that A1 greater than A1 greater than A2 greater than AK, and with distinct parts. So these parts are distinct. So A1 does not equals to A2, does not equals to AK. So they have distinct parts. So now you
Oh,
have to
sorry. Yes.
construct.
Yes. Then yes. That's a good hint, sir. And then I think, well, then if you have the odd numbers and then you can also map the ends
Give
with
me an
the.
element of B. I gave you an element of A, then you give me some element of B. How you will give?
So I will 2a plus 1.
What you want? 2A plus 1. That means
Yes. So 2a1 plus 1.
2A1 plus 1.
That will be odd.
Okay,
So go on like that for the rest of
but
them.
that will be not that will be not integer composition of n. Na? Sorry, that will be not partition of n. That will be partition of some bigger number.
Oh, oh,
Are you getting or not?
yes,
Because
yes, yes,
2a plus 1 will be bigger number.
yes, yes.
So tell me. So let me give you hint example, then you will tell me. Suppose you have this partition 14, 12, 7, 3, 2. Let's say this one. You want to produce this has distinct parts. You want to produce an odd one from this. So how you can write 14? 14 is write the prime decomposition of 14. 7 to the 14. So this is 2 to the power 1 into 7. So this is 2 to the power 2 into 3. This is 2 to the power 0 into 7. This is 2 to the power 0 into 3. This is 2 to the power 1. This you have prime decomposition. So now can you say something? So this means 7 plus 7 now.
Yes, sir.
This
Yes,
means
yes.
3 plus 3 plus 3 plus 3. This means
Just 7.
7. This means
Just 3.
3. This means 2. So you are done.
Yes, 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 yes.
So can you say something now?
So we are the production. So whatever the integer, so whatever the prime factor is, we write that, and then we give it. So we multiply it by whatever the remaining part. So so we have two sevens, then four threes, and
So
five
this is
threes.
intuition. This is intuition. Make it precise. How you will say precisely? I have to write it. Huh?
Okay,
So how you will
sir.
write it precisely?
Okay,
Yes.
okay, one second.
Use the prime decomposition theorem. Any AI can be written as the form of what?
Sir, prime times uh, 2 to the power.
Because only even prime is 2 and this mi will be odd.
Yes,
This will be odd, na?
yes,
Because only even prime is 2. So take 2 separate and mi will be odd. So now AI is of the form 2 ki power k mi. So you can break this AI in the form of this is same thing as mi plus mi 2k times.
yes, yes. Took a repetitions of it.
Yes, 2 to the power k times. So then just break this class. So you have this partition. Na? So let's suppose AI is 2 to the power ki mi. So you construct a bi, construct bi is of the form mi, mi, matlab bi is of the form mi, mi, mi 2 to the power k times. So what will be of b? B is of the form m1, m1, m1. This is 2 to the power k1 times. Is m2, 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 2 to the power k2 times. So on, so on, so on. You have got it, na?
Yes, sir.
So now what about why this will be bijection? Can you
Sir,
give a converse map or you can give surjection, anything? Injection is clear because the prime decomposition is unique.
prime decomposition is itself a bijection, no?
Prime decomposition is itself a bijection. So what?
So if you are using bijection to define the relation, then it must be a bijection.
It must be a bijection, correct? That is a good idea. But how you will do? Let's suppose I give you this partition 1, 1, 1, 1. Let's suppose 4 times 1. Then let's say 3, 5, 7, 7, 7. This is the partition. Let's say I'm giving you. This is from B. So how will construct a some element of A from this?
This is the partition in A. Okay.
Huh. We,
So uh, what we have said. So okay. So you want a formal way of
just
constructing
tell
it.
me, this is just an example. So how you will
Okay.
tell me?
So we have
मतलब, this element, there will be something, some A belongs to A such that f of A is B na. So I want to see this. So can you tell me what is the A basically? You have to give me A which is distinct parts, which have the parts are distinct, such that its image under the mapping which I gave is this element B. So can you give me?
So I mean, you can for this so you can for this so the first five ones you can construct um, five from that. Then 3 and 5 is one. Then 3 7 is one. But I'm confused about is in the prime. So the
You are saying something?
I'm thinking about a formulaic way to construct it, but intuitively you can find one that gives a unique number for this. But I'm trying to think of a
Yes, we have to think formally, na. मतलब
yes,
intuitively
yes,
we can, I can also write directly, but
yes.
we have to think formally. Suppose here A1 is this one is repeating 5 times. Let's suppose let's suppose let alpha I is equals to number of time the integer I repeated. I repeated.
So
So that means
one
what?
question. So in the
Ha,
set
ha.
B, the elements are also partitions.
Yes, yes, yes.
So you have I think can you scroll down to the example?
Hmm.
Okay, no, no. Okay, all right. I saw something else. Okay. Yes. Okay.
Number of times integer I repeated. Let's suppose it is alpha I. So then how I can write this alpha I? So this is some number. So this number, how I can write? This will be, I can write in the form of either in terms of sum of 1 and 2. So I can write this as a sum of 2 to the power I1, I naught, 2 to the power I1, 2 to the power so on. Yes, this is correct. This idea will work, I guess. Can you see now?
So to the power that goes to the power 5.
So
No.
corresponding this, I will construct classes. Suppose you have 1 appearing 5 times. So you can write 5 as a 2 to the power 2 plus 2 to the power 0. So that is what? So 1 is appearing. So 5.1 is 2 to the power 2 plus 2 to the power 0 times 1. So one class will be of 4, comma, one class of 2 to the power 0 dot 1, 4, comma 1. These 5 terms will be break as a class of 4, comma 1. Then 3 is again a class, 5 is again a class, then 7 is appearing 3 times. So 7 is appearing 3 times. So I take this, so 2 to the power 1 plus 2 to the power 0. So 3.7 is 2 to the power 1 plus 2 to the power 0 dot 7. So this will be 2 to the power 1.7 plus 2 to the power 0 dot 7. So this will be break as a class of 2 to the power 1.7 is 14 and 7 to the power 0 is 14, comma 7. So this will be goes to 4 1 3 5 14 7. So yes, this idea will work.
Sir,
Is it clear?
so when so the you started with the partition, but the next one is not a partition, no?
Which one?
So 4 1 3 5 14 7 is not a partition.
4 1. Yes,
So
yes, yes, yes. But we can rearrange it, na?
So,
What
but
is the
then you
problem?
have the confusion of how many ways.
But I just need to give us. I just need
Unique,
to show that
one unique.
this map is surjective.
Uh,
1 1 is already clear to me, na?
yes, yes.
So I just need to go search for surjection.
I was thinking
Should I
actually
write?
initially more in the line so that you combine in place in sort of way. So, so the maybe there is someone.
What you want to say? Can you say again?
Uh, so can you scroll up once?
Hmm.
Uh, so I was thinking if there is some like you have given some 1 to 1 and then 3 5
Huh?
and then 3 sevens. So I was
Huh?
thinking, is there a
Oh,
here?
sorry. I started with a non-partition, yeah. This should be incorrect. So obviously that's why we are getting wrong. Right? So this is not partition. Na? You should tell me. So I should write in opposite way. If I'm writing partition, 7 7 7 3, sorry, 5 3 1 1 1 1. So now it will work, na? 5 times 1. So now it will be 14 7. Then do same thing. This will go to 14 7. That's why I was thinking why this is not right. 5 3. Still it is not correct. 5 3 4 1. So still it is not correct. We need rearrangement still. Huh. Mm. So what we will do?
So can we say that say in between steps, so you are first converting to a tuple, and
Mhm.
that for that tuple there is only one unique partition.
Huh.
So whatever tuple you get, it doesn't matter that you have to rearrange it.
But definition of partition is like this should be in descending order, na?
Yes, you are getting it by exactly one unique partition.
Huh.
So I mean to say that if we know that whatever tuple we get, this is
Hmm.
unique to the partition.
Huh. I got your idea. So you exact directly want to see one to one. That's why I'm also wondering. So how to do? This is clear. This is bijective, but directly it is not clear. Okay. Let's erase this thing. Then write again. But this should be clear now. This is bijective. What you want to see
Yes, sir.
that is correct
Intuitively, I understand that there should be a bijection.
because 1 1 is clear and on 2 I have group 1. So yeah. So B is 2 to the power k m2. So 1 1. So so uh, injectivity. If f of a1 equals to f of a2, that means b is equals to b1 is equals to b2. That means uh, a1 is of the form alpha 1, alpha 2, alpha k, beta 1, beta 2, beta l. So that means what? So if f of a1 is equals to f of a2, so that means their prime decomposition matches. So that means 2 to the power k1 dot uh, I should say m1 dot into 2 to the power k2 dot m2 comes on 2 to the power kk mk is same thing as a beta 1 beta 2. This is 2 to the power l1 n1 comes on 2 to the power ln mn. So that means A1 is A2. So that means F is 1, 1. And for for any B belongs to B, B is of the form B1, B2, Bk. So what you will do, B is of the form B1, B2, Bk. So what you will do, right? So uh, so distinct odd parts it have. So if an integer I is appearing alpha I times, then right alpha I is 2 to the power I naught plus 2 to the power I1 plus 1 2 to the power Ik, and break that class. So break the class corresponding to alpha I dot I as alpha I dot I equals to 2 to the power I naught dot I plus 2 to the power I1 dot I plus dot Ik dot I. So this will give an element A belongs to A such that f of A is B. This implies f is surjective. So these two are one-to-one corresponding. So yes, this is the thing. But what you are saying is correct. So you should think about that, and we can discuss in next meeting. But this time is done. So I will stop here. Stop share. Stop recording as well.